So in my previous class, I have completed the discussion of questions in the assignment in friction from 1 to 20. Next, I am going to discuss the remaining questions numbering from 21 onwards. Come on, look at the question number 21 on the screen. Say the question number 21. Block lying on a long horizontal conveyor belt, moving at a constant velocity, receives a velocity V0 equal to 5 meters per second relative to the ground in the direction opposite to the direction of the motion of the conveyor. After t equal to 4 seconds, the velocity of the block becomes equal to the velocity of the belt. The coefficient of friction between the block and the belt is nu equal to 0.2. The velocity of the conveyor belt is, you have to take g equal to 10 meter per second square. So you can solve the problem by two ways. That is, one is with respect to the frame of reference fixed to the conveyor belt. To solve the problem with respect to the frame of reference fixed to the conveyor belt, the frame of reference fixed to the conveyor belt is moving with constant velocity with respect to the laboratory frame of reference. Therefore, if the laboratory frame of reference is a inertial frame, then the frame of reference fixed to the conveyor belt is also inertial frame. Because conveyor belt is moving with constant velocity, acceleration of conveyor belt is 0, so no pseudo force acts on the block in the frame of reference fixed to the belt. So here, the velocity of the block is V0 directed opposite to the direction of the motion of the conveyor belt. So the velocity of the conveyor belt denoted by V subscript C. So V0 is the actual velocity of the block, actual value of the initial velocity of the block relative to the ground, and Vc represents the magnitude of the velocity of the conveyor belt with respect to the station observed on the ground. So here, so the velocity of the block relative to the belt is towards left side. Therefore, the force of friction sliding friction on block by the conveyor belt acts towards right side. So the velocity of the block relative to the belt is directed towards left side. Therefore, frictional force of the block by the conveyor belt acts towards right side. The other force which acts on the block or its weight mg acts vertically downwards. The narrow reaction force on the block by surface of the belt acts vertically upwards, perpendicular surface in contact, direct away from surface in contact. So if we choose the direction of the velocity, initial velocity of the block relative to the conveyor belt as positive x-axis. So with respect to the belt, here the direction opposite to the motion we take it as x-axis, negative x-axis. The vertical upward direction is the y-axis. So y component of the resultant force is n minus mg, that is 0, because the block has no motion in the vertical direction. So magnitude of normal reaction of the block is same as the magnitude of its weight mg. So X component of the resultant force of the block is equal to minus Fk, because force of kinetic friction acts opposite to motion. That is equal to mass into acceleration of the block with respect to belt. Magnitude of kinetic friction is equal to nu k into n, or nu k into mg. N equal to mg here. So acceleration of the block is equal to minus nu k into g. Up to this step, same calculation applies both with respect to the frame of reference with respect to conveyor belt, and same calculation also holds good even with respect to the laboratory frame of reference. I mean with respect to stationary observer on the ground. Because the conveyor belt is moving with constant velocity, the acceleration of the block relative to the conveyor belt is same as the acceleration of the block relative to the stationary observer on the ground, because the frame of reference fixed to a conveyor belt can be treated like inertial frame of reference. So initial velocity of the block with respect to the belt, you take equal to actual loss of the block minus velocity of the conveyor belt. Velocity of the block is directed to along positive x-axis. Therefore, velocity of the block you can write v naught into I cap. Velocity of the conveyor belt is directed to negative direction x-axis. So velocity of the conveyor belt you can write minus vc into I cap. This is the magnitude of velocity of the conveyor belt. Therefore, initial velocity vi bar is the initial velocity of the block with respect to the belt. That will be v naught plus vc into I cap. So t equal to 4 seconds, the final velocity of the block becomes same as the velocity of conveyor belt. That means the relative velocity of the block with respect to the belt becomes 0 at t equal to 4 seconds. So Vf bar is the final velocity of the block related to the conveyor belt. So I am now doing the calculation from this step onwards. I am doing the calculation with respect to the conveyor belt. So the acceleration is directed in the negative direction of x-axis. So in vector form, the acceleration you can write a bar equal to minus nu k into g into I cap. So using the formula v equal to u plus at or Vf bar equal to vi bar plus acceleration of the block into t. So final velocity of the block related to conveyor belt is 0. Initial velocity equal to v naught plus vc into I cap. The acceleration of the block is equal to minus nu k into g I cap into t. So you get nu k into g into t equal to v naught plus vc. Can substitute all the given values. Nu k is equal to 0.2 here. G is 10 meter per second square. T is 4 seconds. V naught equal to 5 meter per second. So if you simplify this here itself, you get the answer. You get Vc equal to 3 meter per second. So magnitude of velocity of conveyor belt is 3 meter per second. So answer is 3 meter per second. Now can copy down the working. We can also solve the same problem by an alternate method, that is with respect to the stationary observer on the ground or with respect to laboratory frame of reference. In case you need more time to copy the solution of this problem, you can take a pause and take your time. Next, I am going to discuss alternate method for the same problem. So I am going to discuss the same problem with alternate method. I'm going to discuss the same problem, that is question number 21, by the alternate method. Of course, initial part of the calculation is same in both the methods. So just as before, I choose the direction of the initial velocity of the block here towards right, or as before, we take velocity of the conveyor belt towards right here, velocity initial velocity of the block is towards left side. So we can choose the direction of the initial velocity of the block as positive x-axis and vertical upper direction of the y-axis. So the weight mg of the block acts vertically downwards. The normal reaction force on the block by the surface of conveyor belt acts upwards. Initially, velocity of the block relative to the conveyor belt is towards left side. So therefore, force of friction on block, force of sliding friction on block by the conveyor belt acts opposite to velocity of block with respect to the conveyor belt. Velocity of the block with respect to the conveyor belt is directed towards left side initially. Therefore, force of kinetic friction on the block by the conveyor belt will be directed towards right side. So here also same procedure you have to repeat as explained in the previous method. Here also you get the same expression A equal to minus nu k into G. For same, that means same procedure to be repeated up to this step. So now we are solving the problem relative to the frame of reference fixed to the station observed on the ground. That is with respect to the laboratory frame of reference. So initial velocity of the block, with respect to stationary observed on the ground or laboratory frame of the initial velocity of the block is same as equal to V naught, which is direct along positive x-axis, so V naught into I cap. The final velocity of the block becomes equal to the velocity of the conveyor belt. The velocity of the conveyor belt is directed towards right in the negative direction of x-axis. Vc represents magnitude of the velocity of the conveyor belt. So final velocity of the block is equal to velocity of the conveyor belt, means it will be directed towards right side along the negative x-axis. Therefore, the final velocity of the block, you can write minus Vc into I cap at t equal to 4 seconds. Final velocity of the block with respect to station observed on the ground is equal to the velocity of the conveyor belt, which is directed towards right side along the negative direction of x-axis. So in vector form, the acceleration as I discussed can be written as a bar into minus nu k into G into I cap. So again, use the same equation, V equal to V plus at, or final velocity equal to initial velocity plus acceleration into time. So minus Vc into I cap plus V naught into I cap, A bar equal to minus nu k into G into I cap into T. So I cap is common in all the terms. So you get, if you multiply the equation with minus 1, you get Vc equal to minus V naught plus nu k into G into T. You can substitute the given values. V naught is given to be 5 meters per second. Uk is 0.2, G is 10 meter per second square, T is 4 seconds. This you can simplify it, you get 3 meter per second. So magnitude of the velocity of the conveyor belt is 3 meter per second, that's the answer. If you want to copy this working, alternate method also can take a pause and copy down the working. So for the question number 21, which I have discussed just now, first option is the answer. Next, see the question number 22. This question was given one of the previous entrance examinations, same model. Body of weight 92 Newton is pulled by force P. An angle of 37 degrees above the horizontal. On a horizontal frictional surface with uniform velocity of 4 meter per second. The coefficient of friction between the body and surface is 0.2. The value of P Newton is. So this problem also comes under one of the special cases which I discussed in the past. I have discussed the case where we calculated the minimum pulling force required to start the body moving, and the pulling force is applied at some angle theta above the horizontal. The minimum pulling force required to just start the block moving, we can write nu s into mg by cos theta plus nu s into sin theta for given direction of the pulling force. To start the block moving. So minimum value of pulling force required to just start the block moving if it is initial at rest. It's given by nu s mg by cos theta plus nu s sin theta. Once it starts moving, the pulling force required to maintain the motion of the block. The minimum pulling force required to maintain the motion of the block, or you can say minimum value of the pulling force required to move the block along the floor once it is set into motion. Or you can say the pulling force required when to move the block with uniform velocity. Can write same result you can use instead of nu s, you have to take nu k. Nu k into mg by cos theta plus nu k into sin theta. So if you are, this problem was originally given one of the previous entrance examinations in EAMCET. So you can directly use this result for objective type of questions. So here F is equal to P, which you have to find. Nu k is 0.2, weight mg of the block is 92 Newton. Cos theta is equal to cos 37 degrees, we take it as 4 by 5. Nu k is equal to 0.2, sin theta equal to sin 37 degrees, that is 3 by 5. This you can try to simplify it yourself to get the answer. But you can use this result directly while solving numerical problems only when the problem is given in objective type examination, objective type paper or entrance examination. In case you are given a similar problem in board examinations, you have to arrive at this conclusion. Then you have to use the result. So I would like to also again show you the working for same problem as you are supposed to do in case you are given the same problem for board examinations. So in case you are given this problem in board examinations, you have to work out, you have to arrive at the conclusion which I have used, but that means I am again discussing the same question 22 by the alternate method. That is the method which you are supposed to follow in case you are given same model problem in board examinations, in IP exam or any other board examination. So you can draw the free body diagram for the block. So the weight mg acts vertically downwards. The pulling force is applied on the block at an angle theta above the horizontal. The magnitude of this pulling force is denoted by P. The normal reaction force on the block by surface in contact acts perpendicular to surface in contact and directed away from surface in contact. So here if the block is suppose moving towards right with respect to the floor, then force of kinetic friction on the block by the floor acts towards left side. So this is a free body diagram for the block. Can choose the horizontal direction, which is the direction of the motion of the block as positive direction of x-axis, and vertically upward direction as the positive direction of y-axis. Can resolve this pulling force P into two rectangular components parallel to x and y axis. For that we have to construct a rectangle with adjacent sides along x and y axis, such that this pulling force acts along the diagonal of the rectangle. The horizontal component of pulling force will have magnitude P cos theta. The vertical component of pulling force will have magnitude P sin theta. So we have to find the magnitude of normal reaction here. To find magnitude of friction on the block, let Fi denote the magnitude of the vertical component of the resultant force on the body, or y component of resultant force. Let N represent magnitude of normal reaction directed vertically upwards in the positive direction of y-axis. The vertical component of pulling force with magnitude P sin theta is also directed along positive direction of y-axis. The weight mg of the block is directed vertically downwards in the negative direction of y-axis. So y component of resultant force of the block, we can write Fy equal to N plus P sin theta minus mg. That is 0 as the block has no motion in the parallel to y-axis. There is no acceleration in the y direction. So magnitude of normal reaction of the block is equal to mg minus P sin theta. So x component of the resultant force of the block is equal to, you can look at the free body diagram, P cos theta, that is the horizontal component of pulling force which is direct along positive x-axis, minus Fk. Fk represents magnitude of kinetic friction, which is direct along the negative direction of x-axis. From Newton's second law, this can be equated to product of its mass and acceleration. But in this case, the block is moving with constant velocity. So acceleration of the block is 0. Therefore, you get P cos theta equal to Fk. That is magnitude of kinetic friction of the block is equal to the magnitude of the horizontal component of pulling force. But magnitude of kinetic friction of the block can be written as product of coefficient of kinetic friction into magnitude of normal reaction. Can substitute here N equal to mg minus P sin theta. So you can substitute the value of Fk from the first equation into the second equation. This you call second equation. You can substitute the value of Fk from first equation into the second equation. So from first and second equations you can write P cos theta equal to nu k into mg minus nu k into P sin theta. So you can solve for P, can collect the terms containing P to the left hand side. So you get P into cos theta plus nu k into sin theta equal nu k into mg. So or you get P equal to nu k into mg by cos theta plus nu k into sin theta. So now you can substitute all the given values as explained in the previous method and you can arrive at the same answer. In case you want to copy the solution, you can take a pause and copy the solution. So for the question number 22, which I have just discussed now, fourth option is the answer. That is 20 Newton. Next I am going to discuss the question number 23. Block slides down a fixed inclined plane of inclination 37 degrees to the horizontal. The coefficient of sliding friction is 0.25. The acceleration of the block is dash meter per second square. So here this is a direct substitution problem. As I discussed earlier with explanation in the theory part, the block is sliding down fixed rough inclined plane just only under the action of forces mg, normal reaction and Fk, means force of kinetic friction. Then acceleration of the block is given by g into sin theta minus nu k into cos theta. Here g is given as 10 meter per second square. Theta is given to be 37 degrees. Sin 37 degrees you can take 3 by 5. The coefficient of friction is 0.25. Cos theta is cos 37 degrees, you can take it as 4 by 5. This you can, nu k is given to 0.25. So if you simplify this, you get the answer as 4 meter per second square. So for the question number 23, which I just now discussed, second option is the answer. So next see the question number 24. Block of mass 10 kg slides down a fixed inclined plane of inclination 30 degrees with a constant acceleration of 3 meter per second square. The magnitude of frictional force acting on the block during the motion is equal to. So you can write the equation of motion for the block sliding down the inclined plane. That is Newton's second law you can apply. Let us first consider the forces which are acting on the block in this case. So the weight mg of the block acts vertically downwards. The normal reaction force on the block by the inclined surface acts perpendicular to the inclined surface and directed away from the inclined surface. Here n represents the magnitude of normal reaction force. Let Fk denote the magnitude of kinetic friction of the block which acts up along the inclined surface. I choose the direction of the motion of the block as positive direction of x-axis. Direction perpendicular to the motion as y-axis. Can resolve the weight mg into rectangular components parallel to extend axis. The component mg cos theta acts perpendicular to the inclined surface. The component mg sin theta acts down the inclined plane in the direction of the motion of the block. The block has no motion parallel to y-axis. There is no acceleration parallel to y-axis, so y component of resultant force of the block must be 0. Y component resultant force equal to n minus mg cos theta. That must be 0. So resultant force on the block is therefore equal to Fx, means x component resultant force. The x component resultant force of the block. Can look at the free body diagram. The component mg sin theta acts in the direction of the motion of the block along positive direction of x-axis. Fk represents magnitude of kinetic friction of the block which acts opposite to the direction of the motion of the block. So x component as the resultant force of the block. Can write mg sin theta minus Fk. From Newton's second law, this you can write as product of its mass and acceleration. Now we can substitute all the values. The mass of the block is 10 kg. G is 9.8 meter per second square. Theta equal to 30 degrees. Even on the right side you can substitute. Mass of the block equal to 10 kg and acceleration of the block is given as 3 meter per second square. So you can write sin 30 degrees equal to 1 by 2. And can solve for Fk here. So you get magnitude of kinetic friction of the block by the inclined surface is 19 newtons. So answer is 19 newtons. So some of the students may get a doubt, why not we solve the problem by using the same formula which we have used in the previous problem. That means because you are directly given the acceleration of the block, as we already discussed in the theory part, and the block is sliding down the rough inclined plane under the action of the forces weight mg, normal reaction and friction. Then magnitude of its acceleration down the inclined plane is given by g into sin theta minus nu k into cos theta. So the magnitude of acceleration is 3 meter per second square. G equal to 9.8 meter per second square. Sin 30 degrees equal to 1 by 2. Cos 30 degrees equal to 3 by 2. So you can first solve for nu k here. You can find the value of nu k from this. After finding the value of nu k, then magnitude of kinetic friction of the block can be written as nu k into n, and you have to write n equal to mg cos theta. Then you have to substitute theta equal to 30 degrees and substitute the mass m equal to 10 kg, etc. If you do the calculation yourself and simplify it, finally you can arrive at the same answer. If you want to copy down the solution of the problem, you can take a pause and copy down the solution of the problem. So for question number 24, first option is answer, 19 newtons. See the question number 25. Block of mass 2 kg rests on a rough inclined plane, making an angle of 30 degrees with the horizontal. The question is static friction between the block and the plane is 0.7. The friction force on the block is. So first you have to check up whether the block will remain at rest on the inclined plane or the block begins to slide down the incline. So in this problem, tan theta is equal to tan 30 degrees, which is equal to 1 by root 3. You can roughly calculate the value of 1 by root 3. You can multiply both numerator and denominator with root 3. It's not necessary to know the exact value of tan theta here, but you have to check up whether it is more than US or less than US. So whatever you may get after rounding off, you can observe that in this case the value of tan theta is less than the coefficient of static friction. The coefficient of static friction between the block and the rough inclined plane is given as 0.7. That means theta is less than tan inverse US, or angle of inclination of the inclined plane is less than angle of repose, or you can say angle of inclination of the inclined plane to the horizontal less than angle of friction between the two surfaces. So the block therefore will be at rest. As I discussed in the theory, that the block begins to slide down the rough inclined plane under action of force of gravity and contact forces by the inclined plane only if the value of tan theta is more than US, or theta is more than the angle of friction between the two surfaces. But here theta is less than the angle of friction between the two surfaces. Therefore block will be at rest on the inclined plane. So if you draw the free body diagram for the block resting on the inclined plane, the weight mg acts vertically downwards. The normal reaction force of the block by the inclined surface acts perpendicular to the inclined surface and directed away from the inclined surface. You can choose the direction parallel to the inclined surface as x-axis and direction perpendicular to the inclined surface as y-axis. You can resolve the weight mg into components parallel to and perpendicular to the inclined surface. The component mg cos theta acts perpendicular to the inclined surface. The component mg sin theta acts down the inclined plane. Because the block is at rest, the force of friction of the block by the inclined surface can be denoted by Fs, which represents static friction. So x component resultant force on the block, you can write mg sin theta minus Fs, which will be equal to 0 because the block is at rest. Therefore, the magnitude of static friction on the block is same as the magnitude of the component mg sin theta. Already discussed in the theory part that if the block remains at rest on the inclined plane under the action of its weight mg, normal reaction and force of friction, then magnitude of static friction of the block is same as the magnitude of the component mg sin theta, which tends to move the block down the inclined plane. Here the mass of the block is 2 kg. G is given as 9.8 meter per second square. Sin theta equals sin 30 degrees, that is 1 by 2. So you get answer as 9.8 newtons. So for question number 25, which I have just now discussed, first option is answer. See the question number 26. Starting from rest, body slides down 45 degrees inclined plane, twice the time it takes to slide down the same distance in the absence of friction. The coefficient of friction between the body and the inclined plane is. This problem comes under the special case 1 I have discussed in the special cases for motion on the inclined plane. I have separately discussed the special cases related to the motion on the rough inclined plane. This problem comes under the first special case. So you are given similar problem in the previous entrance examinations also. As the result I have discussed is, if T1 is the time taken by the block to slide down the smooth inclined plane, and T2 is the time taken by the block to slide down the rough inclined plane with same angle of inclination theta to the horizontal and same length, then if T2 is n times T1, that means time taken to slide down the rough inclined plane is n times the time taken to slide down the smooth inclined plane with same angle of inclination theta to the horizontal and same length, then the coefficient of sliding friction between the block and the rough inclined plane is given by nu k equal to 1 minus 1 by n square into tan theta. So in the given problem, theta equal to 45 degrees and T2 equal to 2 twice T1, 2 times T1, or n equal to 2. Therefore, nu k will be equal to 1 minus 1 by 2 square into tan 45 degrees. As you must be knowing, tan 45 degrees is equal to 1. So you get nu k equal to 3 by 4 or 0.75. But in case you are given similar problem in board examinations, you have to derive this result which you have directly used, and then you can substitute the values. You are given, in case you are given this method, you can follow. I mean, you can use this result directly only in multiple choice questions or in objective type of question papers in competitive examination. But in case you are given a similar problem in intermediate board examination or any 11th class exam, then you have to derive this result as I already explained earlier. By you have to show the calculation behind this result, which I discussed in special cases. Then you can use substitute the given values. Next, I am going to discuss question number 27. So, question number 26, second option is the answer which I just now discussed. So, look at the question number 27. Block of weight 300 Newton is initially at rest on a rough horizontal floor. In brackets, you can observe nu s equal to 1 by 3 and nu k equal to 1 by 4. A pulling force is applied at an angle of 37 degrees above the horizontal, which is just sufficient to start the block moving. The same force continues to act even after the motion begins. What is the velocity of the block after 3 seconds? As explained in the past, in one of the special cases, that if a pulling force is applied on the block, if you consider block resting on the horizontal floor, if a pulling force is applied on the block at an angle theta above the horizontal, when the block is initially at rest, then the minimum value of the pulling force required to just start the block moving is equal to nu s mg by cos theta plus nu s into sin theta. The minimum value of the pulling force required to just start the block moving, if it is initially at rest on a horizontal floor, is given by F equal nu s mg by cos theta plus nu s sin theta. This formula holds good when the pulling force applied at an angle theta above the horizontal. So for objective type of paper or for an entrance examinations, you can directly use this conclusion already explained this derivation for this conclusion. So in this problem, nu s equal to 1 by 3, the weight mg of the block is given to be 300 newtons. Cos theta equal to cos 37 degrees, which is equal to 4 by 5. Nu s is 1 by 3, sin theta equal to sin 37 degrees, that is equal to 3 by 5. You can try to simplify this yourself. Next, to answer, you have to find the velocity of the block after 3 seconds. You have to find the acceleration of the block during the motion. To find the acceleration of the block during the motion, you must calculate the magnitude of friction force which acts on the block during the motion. To find magnitude of friction for the block during the motion, you have to find magnitude of the normal reaction force on the block. So the pulling force, the magnitude of pulling force is denoted by capital F, which acts at an angle theta above the horizontal. Let us consider the other forces which act on the block. The weight mg of the block acts vertically downwards, which is the gravitational force of the block by the earth. The normal reaction force of the block by surface of the floor acts vertically upwards perpendicular to surface of floor and directed away from surface in contact. In this case, let us suppose the block is moving towards right. Let Fk denote the magnitude of kinetic friction of the block by surface of floor, which acts towards left side, opposing the motion of the block relative to floor. I choose the horizontal direction, which is the direction of the motion of the block as positive direction of x-axis. In vertical upward direction as positive axis. Can resolve this pulling force into rectangular components parallel to x and y axis. Further, you can construct a rectangle with adjacent sides parallel to x and y axis, so that this pulling force acts along the diagonal rectangle. The horizontal component of the pulling force will have magnitude of cos theta. The vertical component of pulling force will have magnitude of sin theta directed vertically upwards. If you simplify this equation on the right side, you get F equal to 100 Newton. So to find the magnitude of kinetic friction, you have to find the magnitude of normal reaction on the block. Let Fy denote the y component of resultant force of the block. You can observe in the free body diagram. Let n represent the magnitude of normal reaction on the block by floor. It acts vertically upwards along positive direction of axis. The vertical component of pulling force with magnitude of sin theta also acts along positive direction of axis. The weight mg of the block acts vertically downwards in the negative direction of axis. So y component of resultant force of the block will have magnitude equal to n plus f sin theta minus mg. But in this case, the block has no motion in the vertical direction. So y component of acceleration of the block is 0 and y component of resultant force of the block is 0. So magnitude of normal reaction of the block by the floor will be equal to mg minus f sin theta. So the weight mg of the block, you can write 300 newtons, given to be 300 newtons, F equal to 100 newtons, sin theta equal to sin 37 degrees, that is equal to 3 by 5. So magnitude of normal reaction force on the block by the floor will have magnitude 240 newtons. Magnitude of sliding friction or kinetic friction on the block during the motion is given by nu k into n. Nu k is given to 1 by 4. Magnitude of normal reaction is 240 newtons. So you get magnitude of kinetic friction of the block by the floor as 60 newtons. So if Y component of resultant force of the block is 0, then the resultant of all the external forces acting on the block will be equal to Fx, means X component resulting force. You can observe that horizontal component pulling force with magnitude of cos theta acts along positive direction of x-axis. Fk represents magnitude of kinetic friction of the block which acts opposite direction of the motion in the negative direction of x-axis. So X component resultant force is therefore equal to F cos theta minus Fk. Here F equal to 100 newtons. Cos theta is cos 37 degrees, which is equal to 4 by 5. Magnitude of kinetic friction of the block is 60 newtons. Therefore, you get magnitude of the X component as a resultant force of the block will be 20 newton. So you first finish copying the solution up to here. There is one more step you have to write. I'll continue this. The next slide, you please finish writing first. So from Newton's second law, the resultant of all the external force acting on the block will be equal to its mass and acceleration. You are given the weight mg of the block as 300 newtons and g as 10 meter per second square. So if you substitute here g as 10 meter per second square, on the left side you get mass of block at 30 kg. So from Newton's second law, resultant of all the external force acting on the block will be equal to product of its mass and acceleration. So magnitude of the resultant force equal to 20 newtons. Mass of the block is 30 kg. Therefore, magnitude of the acceleration of the block, you get it as 2 by 3 meter per second square. The initial loss of the block is 0. The final loss of the block after 3 seconds can be found by using the equation V equal to U plus 18. The initial loss to U is 0 here, or acceleration 2 by 3 meter per second square, T equal to 3 seconds. So magnitude of the velocity of the block after 3 seconds will be 2 meter per second. So that's the answer. If you want to copy the working of the problem, you can take a pause and copy the working.